SRAM's SX 12-speed shifter is one of their mountain bike shifters. In this video, I'm going to measure the cable pull of this shifter and determine the pull ratio of compatible 12-speed derailleurs. Measuring the shifts was straightforward. It shifts accurately and consistently. My indicator doesn't have enough range for all shifts, so I repositioned the indicator in between sets. I took 267 measurements across 3 sets of measurements. Here we can see the amount of cable pulled between each pair of cogs. At the extreme ends, the shifter pulls extra cable because derailleur limit screws control the shifts to the smallest and largest cogs. Pulling extra cable allows the cable to go fully slack when resting on the high limit screw and pulls the derailleur firmly against the low limit screw. Closer to the middle, the shifter compensates for the peculiar way derailleurs move. Derailleurs typically move a little slower towards the ends of their range of motion and faster towards the middle. To compensate, the shifter pulls less cable in the middle than it does at the ends. We can also calculate an average cable pull. I averaged together the middle shifts, ignoring the first and last shifts. The end result is an average cable pull of 3.25 millimeters. You can now use this number to find other shifters that could work in place of this one. I should warn that the various 12-speed systems appear to have different proprietary cog spacings. As a result, each shifter is typically designed to work with a specific cassette and derailleur. This shifter is designed to work with the SRAM Eagle cog spacing, and it is unlikely that this shifter would work well with a different 12-speed system. I've taken the middle 9 shifter steps and created the pull ratio curve for a derailleur that would best match a SRAM Eagle 12-speed cassette. Derailleurs typically have a pull ratio about 2% lower than we'd expect, and I've accounted for that here. I've also accounted for the variable cog pitch of the SRAM Eagle cassette. Here we see the pull ratio curve, and we can observe that it has an average pull ratio of 1.1, represented by the red line. We can use this pull ratio of 1.1 to find derailleurs that could be compatible with this shifter. In fact, I've measured a SRAM SX 12-speed derailleur and found that it has a pull ratio of about 1.09. However, a derailleur doesn't have to have a pull ratio of exactly 1.1 to be compatible with this shifter. Based on compatibility ranges from other group sets, derailleurs with a pull ratio from 1.08 to 1.12 are also likely to work with this shifter. On the outer reaches of compatibility, a derailleur with a pull ratio as low as 1.06 or as high as 1.14 may be compatible. Thank you for watching. I've laid out all the specs here for reference.